In 2026, Israel introduced a new generation of infantry rifles that significantly reshaped how ground forces operate in modern environments. These rifles were not designed as simple upgrades, but as fully modernized soldier platforms built around adaptability, comfort, and precision. One of the most notable changes was modular flexibility. Soldiers can configure the same rifle for close, range urban movement, open terrain patrols, or longer range observations simply by adjusting attachments and optics, without changing the core system. Another major breakthrough was improved ergonomics. The rifles feature better weight balance, redesigned grips, and smoother recoil behavior, allowing soldiers to maintain control during extended use. This directly improves endurance, reducing physical strain during long operations. Advanced optical sights provide clearer visuals in different lighting conditions, helping soldiers maintain awareness without constantly adjusting equipment. Training efficiency also improved. Because the rifle platform is standardized across units, familiarity develops faster and coordination at the squad level becomes smoother. Maintenance requirements were simplified as well, reducing downtime and increasing readiness. What shocked analysts in 2026 was not just the technical quality of these rifles, but how they reflected a shift in philosophy. Israel showed that modern ground combat success depends on comfort, adaptability, and consistency, turning every soldier into a more effective and confident operator. Israel's fighter jet advancements in 2026 focused heavily on improving pilot awareness and workload management. Instead of chasing higher speed or extreme maneuvering, engineers prioritized how pilots interact with information during complex missions. The result was a cockpit environment that feels cleaner, more intuitive, and significantly less demanding during high-pressure situations. One of the biggest changes was improved sensor integration. Radar data, visual tracking, and external inputs are merged into a single, easy-to-read display. This allows pilots to understand the surrounding airspace quickly without shifting attention between multiple screens. Reduced mental strain translates into faster reactions and better judgment during long flights. Communication systems were also refined. Aircraft can share real-time situational data with other platforms, improving coordination and formation awareness. This enhances teamwork in the air without overwhelming the pilot with unnecessary details. Flight control systems were adjusted to provide smoother handling and better stability. These refinements reduce fatigue and help pilots maintain precision throughout extended missions. Analysts noted that these upgrades significantly improve pilot confidence and consistency. In 2026, Israel demonstrated that air effectiveness is no longer about aircraft alone. It is about how clearly pilots see, process, and act, making awareness and control the true foundation of modern air power. In 2026, Israel expanded its unmanned capabilities by deploying long, endurance drones designed for sustained presence rather than short missions. These platforms are built to remain active for extended periods, providing continuous aerial awareness without frequent rotation or interruption. This shift marked a major evolution in how unmanned systems are used. Improved propulsion efficiency and energy management allow these drones to stay airborne longer while carrying advanced sensor packages. The sensors deliver stable, high-clarity visual data across wide areas, supporting planning and coordination. Reliability was a core design focus, ensuring consistent performance in changing environmental conditions. Another key breakthrough was modular design. Payloads can be adjusted depending on mission requirements, allowing the same drone to perform observation, coordination, or communication support roles. This reduces the need for multiple specialized systems and increases operational flexibility. Observers were particularly impressed by how seamlessly these drones integrate into broader operational planning. Continuous aerial data improves timing, awareness, and coordination across different units. Ground and air elements benefit from a persistent overview that supports informed decision-making. In 2026, Israel showed that drones are no longer temporary tools. They are persistent, dependable platforms that extend operational reach and reshape how awareness is maintained over time. In 2026, Israel introduced a groundbreaking development in drone coordination, creating drone networks that function collectively rather than as isolated units. These systems allow multiple drones to share positional and sensor data locally, making decisions and adjusting flight patterns without requiring constant human control. This innovation transforms the way unmanned aerial systems are deployed across wide operational areas. Each drone acts as a node in the network. If one unit encounters an obstacle or environmental change, others immediately compensate, maintaining overall formation and coverage. This ensures that operational awareness remains uninterrupted, even in dynamic conditions. Analysts were particularly impressed by the network's ability to maintain stability and flexibility simultaneously. The scalability of the system is also notable. Small formations or large swarms operate under the same principles, providing adaptable coverage across different mission sizes. This reduces the risk of gaps in observation or support, while allowing efficient use of resources. The system is also highly resilient. If a single drone goes offline, the network continues operating effectively. In practical terms, these coordinated drone groups improve situational awareness and operational efficiency across both ground and air operations. They reduce the cognitive load on human operators while providing persistent monitoring and support. In 2026, Israel demonstrated that drones are not just individual platforms. They are a collective, intelligent system that enhances strategic planning and response capabilities. Israel's laser-based air defense systems achieved a significant milestone in 2026, marking a new era of rapid, precise, and sustainable defense. Unlike traditional interception systems that rely on missiles or projectiles, laser defense platforms use directed energy to neutralize airborne objects almost instantly after detection. This shift emphasizes efficiency and operational continuity. One major advantage is speed. Lasers operate at the speed of light, allowing immediate engagement of incoming aerial elements. Reliability improvements mean these systems perform consistently even in varying weather conditions or complex operational environments. The systems can engage multiple targets in rapid succession without the need for reloads, providing uninterrupted coverage during prolonged operations. Another key feature is sustainability. Laser systems operate at minimal per-use cost, unlike conventional interceptors that require expensive ammunition. This allows defense units to maintain long-duration operations without logistical strain. Analysts noted that these systems dramatically reduce the complexity of large-scale defensive planning, as sustained operations are now possible without constant resource replenishment. The 2026 deployment also included advanced targeting integration. Laser platforms communicate with aerial sensors and radar networks, allowing operators to prioritize threats efficiently. This ensures the system remains precise, responsive, and adaptable under various scenarios. In essence, Israel's laser-based air defense demonstrates that modern protection is not about brute strength, but about speed, precision, and continuous coverage, fundamentally changing how strategic defense is planned. Another 2026 breakthrough was the integration of drones directly with infantry operations, creating a seamless awareness system that enhances ground-level performance. Soldiers can now receive real-time data from drones flying overhead or ahead of operational areas, providing an eye-in-the-sky perspective that improves navigation, hazard detection, and situational planning. These systems allow soldiers to identify obstacles, map terrain, and maintain continuous observation without exposing themselves unnecessarily. The integration is designed to be intuitive. Data is transmitted directly to squad-level devices, providing actionable information in a simplified, easy-to-read format. Flexibility is a major advantage. Infantry units can coordinate with drones for reconnaissance, communication relay, or support observation. This reduces reliance on multiple external systems while increasing operational efficiency. Drones can reposition dynamically, following the unit as it moves, or providing extended monitoring for stationary positions. Analysts noted that this pairing of ground units with unmanned aerial systems dramatically reduces information gaps, improves coordination across squads, and enhances decision-making speed. Soldiers benefit from a continuous overview of their environment, allowing for smoother planning and movement. In 2026, Israel showed that infantry effectiveness no longer depends solely on individual equipment. Instead, it is amplified by smart integration with aerial systems, creating a combined force that leverages both human decision-making and technological awareness. In 2026, Israel significantly improved cross-domain coordination between naval and aerial platforms, particularly over coastal and littoral regions. Previously, operations in these areas relied on separate control systems for air and sea, leading to delays, blind spots, and fragmented awareness. Israel's breakthrough was to integrate these domains into a single operational framework that allows seamless information sharing between aircraft and naval units. The system merges radar feeds, positional tracking, and communication networks, providing commanders with a unified operational picture. This enables simultaneous monitoring of aerial and maritime activity, ensuring that units can respond cohesively to changing situations. Analysts noted that even complex scenarios, such as coordinating multiple aircraft and ships across large areas, could now be managed in real time without confusion. Another critical improvement was automated prioritization. The integrated system evaluates activity levels, potential hazards, and environmental factors, highlighting key areas for attention. This ensures that both air and naval assets focus on the most relevant objectives efficiently. Units can maintain synchronized movement, allocate resources effectively, and avoid overlap or redundancy. In practice, this development enhances situational clarity, resource efficiency, and operational readiness. By 2026, Israel demonstrated that integrated control across air and naval domains is no longer optional. It is a strategic necessity for maintaining dominance and awareness in critical regions. Another groundbreaking 2026 development was the expansion of high-fidelity simulation environments for both air and ground units. These platforms provide immersive, realistic training scenarios without the need for costly field exercises. Soldiers, pilots, and drone operators can now experience dynamic situations that replicate real operational conditions with near-perfect accuracy. The simulations adjust automatically based on trainee decisions, providing adaptive feedback that improves learning speed. For example, if a squad makes suboptimal tactical choices, the system introduces realistic consequences and alternative strategies, allowing personnel to understand the impact of their actions without risk. Similarly, pilots can practice complex maneuvers, coordination, and situational awareness repeatedly until proficiency is achieved. Integration with live unit data adds another layer of realism. Trainees can see simulated units responding to real-time inputs, bridging the gap between training and actual operational environments. This approach reduces preparation time while improving confidence, accuracy, and adaptability under pressure. What shocked observers was how simulation environments now allow multi-unit, cross-domain exercises that previously required extensive resources. Ground forces, aerial platforms, and drones can operate together in a virtual framework, maintaining the same communication and coordination as in live operations. In 2026, Israel demonstrated that preparation and readiness no longer depend solely on real-world practice. Instead, training is accelerated, smarter, and fully aligned with modern operational complexity. In 2026, Israel achieved major advances in communication networks, focusing on stability, security, and adaptability. Traditional networks often struggle under high operational load or in complex environments, but Israel's new system automatically adjusts to maintain reliable connectivity across all units, including infantry, drones, and aerial platforms. The system incorporates adaptive protocols that continuously monitor signal strength, bandwidth availability, and environmental interference. When conditions change, it dynamically reallocates resources to maintain uninterrupted communication. This ensures that units remain connected, situational awareness remains accurate, and coordination remains seamless even in unpredictable operational contexts. Security improvements were equally notable. Advanced encryption and automatic protocol adjustments protect sensitive information from interception while maintaining efficiency. Operators and commanders can communicate in real time without compromising data integrity, allowing both planning and decision-making to proceed confidently. Observers highlighted how this development enhances synchronization across domains. Ground units receive timely updates from drones, air platforms, and naval assets, while commanders maintain a unified understanding of operational conditions. This reduces delays, confusion, and information gaps. In 2026, Israel showed that reliable and secure communication is no longer just a support function. It is a strategic advantage. Continuous connectivity enables rapid, informed responses and ensures that technology and personnel operate in a coordinated, efficient manner. The final and most transformative breakthrough of 2026 was the integration of artificial intelligence as a unified decision support system. Unlike traditional AI implementations, which often operate in isolated areas, Israel's AI connects infantry, drones, fighter jets, and naval platforms into a single operational framework, allowing commanders to access coherent, actionable insights from vast streams of data. AI monitors sensor inputs across domains, identifies trends, and presents optimized options to decision makers in real time. For example, drone observation data, aircraft monitoring, and infantry positional reports are fused into a single picture, highlighting areas that require attention or adjustment. This significantly reduces cognitive load and improves timing, as commanders no longer need to manually correlate multiple information sources. Crucially, this AI system supports human leadership rather than replacing it. Humans still make final decisions, but AI provides predictive modeling, rapid analysis, and scenario evaluation, accelerating response and improving accuracy. It can simulate thousands of possible outcomes in seconds, highlighting the most effective strategies under given conditions. Observers were shocked by how smoothly AI coordinates across ground, air, and unmanned systems. Every platform operates in sync, improving efficiency, reducing confusion, and maximizing operational effectiveness. In 2026, Israel demonstrated that the future of defense is not only about advanced tools, but about faster, smarter decision-making, where AI functions as the central nervous system, connecting all assets into one powerful, responsive network.